At the end of the topic, you will be able to define work, state the SI unit of work.
What is work? Guess who is working in the following example. A man is carrying a heavy load on hand and standing in a place, and the other man carrying a heavy load on his back and walking. Now it is quite difficult for you to decide. The technical meaning of work is exactly different from the common usage. In physics, work is done when an object moves to a certain distance or if there is a change in displacement under the action of force.
In day-to-day life, we use the term work to mean any physical or mental effort. Pushing, pulling, throwing, pressing, kicking, stretching, turning, and bending are examples of physical effort. Memorizing poems or solving mathematical problems involve mental effort. These types of work or effort cannot be measured. But in physics, work is a measurable quantity. Now, let us see an example for work as per physics. Lifting a book from the ground and putting it on a shelf is a good example of work. Therefore, work is done by a force on an object only if the force causes the object to move in the direction of the force. Objects that are at rest may have many forces acting on them, but no work is done if there is no movement. Work is the transfer of energy through motion. For work to take place, a force must be exerted through a distance. The amount of work done depends on two things. They are the amount of force exerted and the distance over which the force is applied. There are two factors to keep in mind for deciding when work is being done. Something has to move and the motion must be in the direction of the applied force. Work can be calculated using the following formula. Work is equal to force into distance. Work W is done when a force F acting on a body moves it to a distance S in the direction of the force. W is equal to F into S. Therefore, work done is defined as the product of the force and the distance over which the force is applied. Now, click the animation button to know more.
The SI unit of work is Newton meter, Nm. It is also named as Joule, J. This unit being named in honor of James Prescott Joule, that is, 1 Newton meter is equal to 1 joule, where 1 joule is the work done when a force of 1.0 Newton acting on an object moves it through a distance of 1.0 meter along the same direction.
The larger units of work used to measure large quantities of work are kilojoules and megajoules. 1 kilojoule is equal to 10 power 3 joules. 1 megajoule is equal to 10 power 6 joules.
While going in a car, if the car fails to start, the driver asks us to push it from the back. Here, the force applied and the direction of displacement is in the same direction. In this case, the work done by pushing is positive. Think of you and your friend playing with a cricket ball. As he throws a ball towards you, you take a catch. Here, the force required to stop a ball acts opposite to the displacement of the ball. The work done in this case is negative. When a force acts at right angles to the direction of motion, work done is said to be zero. Similarly, work done on an object moving in a circular path is also zero. This is because the centripetal force that keeps the object in the circular path is acting along the radius of the circle and is at right angles to the direction of motion.
In this topic, you have learned work is said to be done when a force acts on a body and the point of application of the force is displaced in the direction of force. Work W is measured as a product of the force F and the displacement S in the direction of the force. The SI unit of work is joule. The larger units are kilojoule and megajoule. At the end of the topic, you will be able to
Define power, explain energy and its various forms, express the practical unit of electrical energy, describe the ways of obtaining energy.
You have seen different automobiles. To understand the concept of power, consider a car and a bike. Car can carry about 5 people and can travel 150 kilometers in an hour, whereas a bike can carry 2 members and go maximum of 90 to 100 kilometers in an hour. Which does more work in 1 hour? Yes, car does more work. Let us see another example. Tom and Tim are building a wall with bricks. Both could accomplish the work. The amount of work done is the same, but the time taken differs. Thus, work done and work done per time are different. The rate of doing work is a measure of power. Power, by definition, is the time rate of doing work.
We know that energy exists in different forms. All forms of energy are associated with motion. Energy is needed to move objects. In other words, the ability to do work is called energy. The word energy is derived from the Greek word energia, which means in action or work. It can be measured by the amount of work done. The commercial unit of electrical energy is kilowatt-hour, kWh, and it is commonly known as unit. 1 kilowatt-hour is the energy used in 1 hour at the rate of 1000 joule per second or 1 kilowatt. 1 kilowatt-hour is equal to 1 kilowatt into 1 hour is equal to 1000 watts into 3600 seconds is equal to 36 lakh joules is equal to 3.6 into 10 to the power of 6 joules. The energy consumption in industries, commercial establishments and households are expressed in kilowatt-hour.
Whether it be launching of rockets or lifting a book or a falling snow, it is energy at work. Energy has different forms: light, heat, movement, sound, and electricity. Energy always keeps changing form. It can also be stored. A glowing bulb converts electrical energy to light energy. Stove converts fuel into heat, and loudspeaker converts electrical signal to sound. Click each button to know the different forms of energy and their applications. If you stand near the furnace, what do you feel? You feel so hot. Rub your hands together. What do you experience? Yes, it is hot. Heat has the ability to do work. Heat cooks food and produces light. Heat has the power to expand objects, and heat can move objects. The flow of electrons causes electric current. Electrons are driven by electrical potential to move across the conductor. We use electrical energy in different forms. We use electricity to run fan, motor, machinery, lamps, and many more. Electrical generators, batteries, and cells supply electricity. Sun is the source of all forms of energy. Solar energy is used by plants and is used for making and storing food. Solar panel converts solar energy into electrical energy, which is used up in lighting and cooking and in transportation. The heat energy from the sun heats up the sea water, which causes a water cycle, and also nowadays used by the ocean thermal technology in generating electricity. Nature uses solar energy to the fullest. Plants use sunlight in photosynthesis. The man uses it in some devices like solar panels and solar cells to produce electricity. Energy is released during certain chemical processes. Food gives us energy by biochemical process, and so we call it biochemical energy. Fuels such as gasoline and petroleum products and food are forms of stored biochemical energy. This chemical energy can be converted into other forms of energy. Enormous energy is released during nuclear reactions. Nuclear fission and nuclear fusion are the two forms of nuclear reactions. Breaking up of heavy nucleus into two or more nuclei is called as nuclear fission. Combining two or more nuclei into single nucleus is called nuclear fusion. Energy released by nuclear fission is used to produce electricity.
We know about the various forms of energy and energy conversions, but where does an object get its energy from? There are actually two ways by which an object gets its energy. The object will get energy when one form of energy gets converted to another form. It can also get energy whenever work is done. Let us try to understand the two ways of obtaining energy in detail. Energy can be obtained through energy conversion. This is based on the law of conservation of energy, which states that energy can neither be created nor destroyed, but it can only be transformed from one form to another. The alternative statement of the law of conservation of energy is that the total amount of energy in an isolated system remains constant but can be transferred from one object to another within the system. Here, system refers to the object of our study. If we take any form of energy, we find that it was obtained from some other form of energy, and that form of energy also from another form, and this gets continued to form an endless chain of transformation of energies. Hence, whenever we say we use energy, it conveys the meaning that we are converting one form of energy to another form. Let us take a few examples to understand this energy conversion. Click on the example button to view the examples. Example 1. In the case of the motion of a car, it is the chemical energy of the fuel when burnt produces heat energy, which in turn gets converted into mechanical energy. Example 2. In the case of windmills, it is the wind energy that gets converted to mechanical energy, which in turn runs a turbine to produce electricity. But heat from the sun causes wind to blow. The source of sun's energy is nuclear fusion reaction. This leads to the chain of transformation of energies. Example 3. In the case of electrical appliances, electrical energy gets converted to light energy, mechanical energy, heat energy, and so on. Example 4. The cooking of food is a chemical reaction which can be transformed into energy inside the human body. When we apply an external force in lifting an object, we say work is done on the object. When we do work on the object, energy is transferred to the object. In other words, there is an increase in the energy of the object. Energy gained by an object is measured in terms of the work done on the object. Let us take an example of a compressed spring. In the compressed state, work is done on the spring, which is stored in the spring as energy. On the other hand, when the spring gets released and comes back to its original position, the same amount of energy is recovered as work in pushing the ball. In this topic, you have learnt power is defined as the rate of doing work. It can also be defined as the work done per unit time. The capacity to do work is called energy. The SI unit of energy is joule. Law of conservation of energy states that energy can neither be created nor destroyed, but it can only be transformed from one form to another.